Okay, guys, so we're looking at the last section in 3.6. This is going to have to do with when we have a different type of rational function where we actually end up with a slant asymptote. We haven't really talked about slants too much yet. On the back of this, we've got some extra room here. I want to talk about those rules for asymptotes. So let's say we start with 3x over x squared minus 4. Does anybody know what the asymptote would be in this case? Okay, vertical asymptote, yes, would be at 2 and negative 2. Agreed. But what about horizontal? Do you know what the rule would be here for the horizontal? Nope. When the power is higher on the bottom, we always have a horizontal asymptote of 0, y equals 0. If you don't have that memorized, that rule memorized, you can just find the limit as x goes to infinity. If I plug in infinity, I get infinity over infinity, but I can use L'Hopital's. Take the derivative of the top, take the derivative of the bottom. What do we get now if we plug in infinity? What's anything over infinity? 0. That's the reason why that is the horizontal asymptote. All right, so now let me change this function a little bit. Same thing, except I'm going to put a squared now on the top. So same vertical asymptotes, we're just worried about horizontal. Anybody know it? It is 3. The rule is when the powers are the same, we divide the lead coefficients. So it's y equals 3. Let's say we didn't know that. Well, we can find the limit as x goes to infinity. We get infinity over infinity. We use L'Hopital's. We reduce that, and we get 3. Okay? So lots of different ways we can find these horizontal asymptotes. The last case, though, is this. What if I have 3x squared just over x minus 4? This is the case we haven't talked about a lot. When this happens, I try to use L'Hopital's. I try to find that limit as x goes to infinity. I get infinity over infinity. I take the derivative. I get infinity. When I get infinity, that means I actually have the function going way up to infinity, which means we have a slant asymptote. 2 ways you can find the equation of a slant asymptote. The first way is with long division. I do x minus 4 divided into 3x squared. 3x squared divided by x is 3x. I multiply, I get 3x minus 12x. I have to subtract, so I'm going to put a 0x there. When I subtract, I get a 12x. 12x divided by x is 12. I can't divide anymore. So that's going to be my slant asymptote. The faster way to do it, if you understand, is to do synthetic division. If you can remember how to do that. What I do is I look at the denominator. What makes it 0 is 4. That goes in a box. I use my coefficient. There's the coefficient of x squared. There's the coefficient of x. There's my constant. I bring down the 3. 4 times 3 is 12. I really don't even care about the rest of this because this is just a remainder. It doesn't affect anything. So this now tells me that my slant asymptote is y equals 3x plus 12. Okay? So now let's go back to our example over here. So our goal is to sketch the graph. On the next quiz, you can't use a graphing calculator because you really don't have to know any calculus. I mean, if you have a graphing calculator, you can graph it, then use the graph to fill in the chart. If you want to use non-graphing calculator, that's fine. So we're going to sketch the graph using the provided table to organize the data. We're going to find critical numbers, vertical asymptotes, PPIs. We're going to find intercepts if we have them, relative extrema, all the stuff we've been doing. All right, so you always want to start, first of all, by finding the vertical asymptote. What is it? X equals 2. That will go in our chart. The next thing we're going to find are the critical numbers. That's whatever makes this first derivative 0 or makes it undefined. So if I factor that numerator, I get that. So what's going to make that 0? 0 and 4 are going to be critical numbers. What makes this undefined? 2. But 2 is already a vertical asymptote, so it can't be a critical number. It can't be a max or min. It's a vertical asymptote. Do we have any possible points of inflection? Anything that makes this 0? 2 makes it undefined, but it's already a vertical asymptote. All right, so these are the things that are going to go in our chart. I've got 3 values that go in the chart. If I double and add 1, that's 7. That's how many rows I'm going to need. So I'm going to have to go from negative infinity to 0, 0, 0 to 2, 2, 2 to 4, 4, and 4 to infinity. Just like on your worksheets and on the quiz, I may give you too many rows. I don't want to tell you how many are going to be there. You've got to figure that out. All right, so this is what we've got. So now we're going to go ahead and we're going to check some values. I'm going to check negative 1. I don't have to plug that into my original, just into my derivative. Now, a time saver. What is always going to be true of this denominator if it's getting squared? Positive. I'm not even going to worry about the denominator there. I'm just going to plug into the numerator. So negative 1 times a negative, negative times negative is a positive. Plugging into my second derivative, a negative 1 minus 2 to the third is negative, so that's negative. So now I know that the function is increasing and concave down. I plug 0 only into the original, and I get negative 2. I don't use these. Okay, so now I need to check this. 1, I'll plug that into my first derivative. That's going to be positive times negative. That's negative. I'm going to plug 1 in here. That's negative. So now I'm going to be decreasing and concave down. This was a critical number. We're going from increase to decrease. Increase to decrease. What do we have to have? Max. There's my point where I have a max. What was 2? We already know what it was. Vertical asymptote. It made this undefined. That's why. Okay, 2, 4. I can plug in 3 into my first derivative. Positive times negative, negative. Plug 3 in here. That's positive. So we're going to be decreasing and concave up. 4 goes back into the original. 4 squared is 16 minus 8 is 8 plus 4 is 12 over 2 is 6. I'm going to wait on that. I want to see what that is later. I'm going to plug 5 into my first derivative. That's positive. That's positive. So it's increasing and concave up. This was a critical number. It goes from decrease to increase. What do we have to have right there? Minimum at 4, 6. All right. So I'm going to go ahead and put in my vertical asymptote. Before you start graphing, though, you need to know whether you have a horizontal or a slant asymptote. Look at the powers. What's it going to be? Slant. When that denominator power is less. See, here's the way I think of it. Can I divide x squared by x? Yes. So that means I can use division. So it's going to be a slant asymptote. All right. So what do you guys want to use, long division or synthetic? Okay, so synthetic, I put 2 in the box. I do 1, negative 2, 4. I bring this down. That's 1, that's 2, that's 0. Don't care about the rest. So what is my slant asymptote? Just y equals 1x. Not just 1, 1x. Because this is the x position, this is the constant position. So y equals x. So I want to put that down here y equals x is this line. Okay. So now we're going to go back up here. From negative infinity to 0, I had to be increasing and concave down. I know I have this point of 0, negative 2, and it has to be a max. So I had to be increasing. That slant asymptote's giving me a guideline. Then I had to go to decreasing and concave down. So it looks like that at that part. I get to 2. I have my vertical asymptote. From 2 to 4, we had to be decreasing and concave up until we get to the point 4, 6, which is right about there. So from 2 to that 4, I had to be decreasing and concave up. And then once I go to 4 to infinity, increasing and concave up, use those asymptotes as guidelines. And there we go. It's not too hard, is it? It's just a matter of looking at that chart. We can use our graphing calculator to check, but not to do the whole thing. Guys, I'll show you this if you have one of these newer calculators. This is one of the newest ones. It's cool. I don't know if I've shown it to you. But if I go to alpha F1, I can get this little fraction thing, and it's easy to put this in now. We're always kind of making advancements on these things. So now I can type it in exactly the way it looks. I do a zoom 6, and it's going to go ahead and graph that, and I can check and see if my graph looks correct, and it looks good. And I'm going to go ahead and also put in that slant asymptote just to see how that all fits in there so nicely. So see how that slant asymptote just comes right up in there? Okay. All right, so you guys have your